Hello, everyone. We are the Accessible IoT group, and my name is Jacob.
I'm John. Haka. Matthew.
And so for our project, we were tasked with taking IoT systems, which are a really neat and interesting tool for providing extra functionality in our lives, and expanding those to a much wider user base. So there are two core groups that we want to try and serve in this. And those are people who are in rural areas that may not have as consistent of internet connections or power grids, and also people who have accessibility needs who aren't able to use standard sort of IoT input devices. So we chose to name our project EASE, which stands for Enclosed, Accessible, Smart Environment, because we wanted to create an offline system which will be able to run in more remote locations, and it's also going to be more secure. And then we also want it to be an accessible system so that as many users as possible are able to use our solution.
So before we get into the design proper, I'd like to introduce you to a couple of the names that might come up while we explain our rationale for a few of the designs. The first one up there, Jackson Pang, is our client. He works with Cisco. He's a security engineer. He lives in Palo Alto. His inspiration for the purpose of this design is he tutors a child with cerebral palsy. Another one of the people that we've discussed with for the research phase of this project is Alex Fung. He's a student and he lives on campus. He's a tetraplegic, and he works with the QL Plus Club. For those of you that don't know, it stands for Quality of Life Plus, and they work with different technologies that are designed to make things more accessible for people with some sort of disability.
So that brings us into our customer groups. So we decided for our projects that we wanted to focus more on the accessibility component, which meant that our core customers would be people who actually have disabilities and the elderly, as they frequently need some sort of accessibility option. And then there are other groups that we wanted to pay attention to, and these are rural residents, and then finally security concerns consumers. And so the rural residents to get accessibility out to those more remote locations. And then Jackson also specifically requested that we do a little bit of research to pay attention to the security component of the project so that these groups wouldn't be made vulnerable by our system. And so then we also have on the left our three personas. So starting in the top left corner, we have Giovanni, who is a youth who is wheelchair bound, and he has a live-in caretaker. So this is a relatively common situation for a lot of people who are unable to fully take care of themselves. Then we have in the top right, Harold, who's an elderly gentleman, and in the bottom we have Odal, who lives out on a farm where she doesn't have consistent internet access or a fantastic power grid. So how do these customers then drive our customer requirements? So we found that just as with our customers, we kind of group our requirements into two categories. So we could focus on the ability requirements and then the environmental requirements. So starting with the ability focus, we found that people with disabilities are usually unable to perform tasks that are required for maintaining a lot of devices. For example, when setting up most smart lights, there's the obvious step of climbing up to the ceiling to install a light bulb, which a lot of people are unable to do. And then there's also frequently a step where you may have to toggle a light switch frequently or pay attention to a complex setup process. And so we want to make our system minimize these steps as much as possible. And especially once these setup steps have taken place, we want to have no more steps that the end user couldn't perform on their own. So we want it to be as maintainable or as low maintenance as possible. We also want to make sure that our system is able to be extended to as many users as possible. And so we found out from speaking with Alex that a lot of accessibility solutions are tailored for one specific individual rather than being general purpose solutions. So we felt that rather than making a system that is a solution in and of its own, we wanted to focus on creating a system that can be modified and extended to as many other systems as possible with minimal work by the end user. So we decided it would be very important to have our system be both open source and to make sure that it has a sort of layer for interfacing with accessibility devices and common types of accessibility devices, And then we also want to support consumer IoT devices so that our system is opening up as many technologies as possible. Moving forward to the other half of our customers, we found that, we found that one of the major restrictions for rural areas is that the power grid and internet situation isn't going to be reliable. So we wanted to make sure that our system would be resilient against power surges. We want to make sure that it could recover after some sort of connection drop, has like a backup power kind of system. And then finally, we wanted to make sure that our system didn't make people more vulnerable. And so we wanted to make sure that we have paid attention to common security concerns and set up sort of baseline security like encryption and things so that users won't be placed at risk. And then the very last component is to make our entire project run offline so that it's flexible in both where it can be deployed and is more secure overall.
All right, now we have the engineering specification table, and I'll be explaining the functional and the non-functional requirements. These consist of requirements that were given to us by our client Jackson, and requirements that we decided upon as a team to better improve the experience for our customers. So beginning with the offline operable component, that means that the system utilizes absolutely no internet connection. That further implies that it's not connected to any big data like Facebook, like the Amazon Echo, Samsung SmartThings, stuff like that. And so with that comes inherent advantages, especially with regards to security concerns, privacy concerns. It'll be immune to external threats like malware and unwanted data transfers. And then second, we have the Zigbee and Z-Wave compatibility. For those of you who may not be familiar with Zigbee and Z-Wave, they're like Bluetooth and Wi-Fi. They're communication protocols, and they're mostly commonly used for home appliances. So we decided to implement both Z-Wave and Zigbee because a lot of these home appliances only use one communication protocol. And so by having both of these, that would give more options for customers. And then for final, most important takeaway from our functional requirement, we have the backup internal power. This will provide approximately 100 minutes of backup internal power. And then now off to the non-functional requirements. We have the ease of setup, user-friendly accessibility interface, and the open source component. As for ease of setup, we're going to provide a step-by-step guide. And since this project is geared towards people with disabilities, accessibility needs, and the elderly, we thought that as an ease of setup is a must. And then similarly, a user-friendly accessibility interface. As Jacob and John mentioned, we interviewed Alex, and we decided that a wheelchair input device, a wheelchair joystick, would be a great input device for a project. And then for the open source component, we're going to upload everything to GitHub, and it will be available to the public.
So I'm going to be giving a brief overview on our system. And so as you can see here, this is a high-level block diagram of what we want to implement. And so it can be divided into 3 parts. The first part being the input device, which is what the user will use to control the smart home hub via Bluetooth. The next part is the smart home hub itself that will take the user input as well as manage end devices like outlets, lights, and whatnot. And then the last part is the IoT devices themselves. So like thermostats, lights, smart outlets. And so the 2 main parts that our project focuses on is the input device and the smart home hub. And because we want to target as many end IoT devices, that isn't really much of a focus to us. And so there's 2 key decisions that we have to make when we were designing this. The first being what input device. And so after meeting with Alex, we decided to kind of narrow it down to these three because there exists a wide variety of accessible input devices. And so the first option is a wheelchair joystick, which is, as the name implies, a joystick that's mounted on the wheelchair. Occasionally, these joysticks also have user programmable buttons, which the user can use to control other things. Next is the quad stick, which is also like a joystick, except it's controlled via the mouth. I guess one of the benefits of the quad stick is its precise control. However, because it has to be positioned in front of the user's mouth, it does require setup each use. And then the last option is the large button, which is a large button. And so this is the most accessible because it requires no precise motor skills. However, it does severely limit our input options because you can pretty much just do like a single press, a double press, a triple press even, but anything more than that might be harder to do, especially with those that lack fine motor skills. And so we decided to just stick with the wheelchair joystick because one, there already exist commercially available wheelchair joysticks that have programmable buttons as well as Bluetooth capability. And so we don't necessarily need to implement a Bluetooth interface. However, one con with the wheelchair joystick is that it will be inaccessible out of chair. And so hopefully in the future, we can expand to other accessible inputs. The second key decision that we have to make was also how to implement the smart home hub. And so at first, we discovered Hubitat, which is a commercially available option that kind of acts like an intermediary between like Google Home or Amazon Alexa. So it kind of interprets those commands. But I guess the interesting part is that it's completely offline. And so it doesn't communicate to like the cloud. However, we discovered that it has a fairly high price point, as well as the fact that it isn't open source. And so with that in mind, we decided that since we have a few Raspberry Pis laying around, we discovered that there exists pre-existing home automation software. And the two major ones that we looked at are OpenHab and Home Assistant. Both are open source and offline capable, and they both provide fairly accessible user interfaces. However, we decided to go with OpenHab because it has a large community, which means that it has rather extensive documentation as well as better support.
So now we're going to open up to questions before we go through our demo. So when we were looking at it, our main goal was to find something that would be like consistently reliable and something that would stay with the user at all times. So wearables also fit that bill, but when we were doing our research, most of the devices, like the most thoroughly presented devices that we found, we found the wheelchair joystick was like a more complete package with like more heavier documentation. And so we felt it would be a little bit easier to set up in the long run.
So what would be an example of something that would control the joystick?
So, so sorry, to clarify with the joystick, the input that the user would use to control our system would be reprogrammable buttons. So it's kind of hard to see on, let's see, actually it's way deeper into the PowerPoint. But anyway, so the joystick, like the actual joystick element is for controlling the chair. And then a lot of wheelchairs also have programmable buttons that you can then map to some sort of function. So we found a brand, I believe it was Mobile, that had 4 reprogrammable Bluetooth buttons. And so then we would just have to make an interface that could receive that Bluetooth command and then process that on in our Raspberry Pi. But yeah, so it's not the joystick itself that you use to control. It would be more like input type buttons. So you could use that to say like have a button mapped to your bedroom lights, or you could have a buttons mapped to like a thermostat, things like that.
So why did we talk about the joystick in the first place? I'm confused.
So by the joystick, we're referring to like that entire unit. So you can purchase like a wheelchair joystick that is a unit that contains it's like the wheelchair controller and has those reprogrammable buttons in one device. Like that's all processed by one device that's like the output screen, so that the user can see like battery life and stuff in the wheelchair.
So for the purposes of your design, the one large button and the wheelchair joystick is for the difference in the number of buttons?
Also, it's a difference of motor function while using it, right? So like we mentioned, the large button, it would be like a giant large button.
Right.
And you would, like the buttons on the wheelchair joystick are smaller, right? Still accessibility focused, so they're still soft, but like it's not just a question of like that, but also whether or not you always have it on you, and if you're in a wheelchair, you have the controller for the wheelchair with you. So having like always having a button with you would kind of be, it'd be a little bit like, what's the word I'm looking for? Not, yeah, inconvenient or clunky or something. Just always having like a button sitting on your Bluetooth or sitting on your wheelchair.
So you were talking about when you had your conversation with Alex that you wanted to make your project more open source and available for general use, not just one use case. Is this like using the joystick with buttons on it? Is that sort of one use case, not making it general purpose?
So our goal with the project is, as we're building up the entire project, the flow of execution, like at each point we're going to try and make modular, but we also want to have a full end-to-end demo. And so we have to choose a specific device to actually implement. And so then like through that implementation process, we'll get to see what components of like how connecting two components together really works, like how we can kind of modularize that interface. But it was mostly because like we don't have the time to do several different input devices, so we just had to pick one to kind of focus on for the sake of the project.
So is the hub the portion that should be general use and it should take any type of input? Is that what you mean by the?
Yeah, so the idea is to like kind of extend the hub so that it has some sort of interface, like as an abstract idea of it, just like a Java interface or something that would then allow the end user to take an accessibility device and then pick a similar type of interface, like if you just had like a button type interface, or if you had like maybe for something like a quad stick, you had something that was like a joystick type interface. And so yeah, it's just to modularize it there and then implement one option.
So if I understand this, you're trying to make sort of a compatibility layer that supports various very simple to maybe more complex encodings. I say very simple, such as maybe something as ambitious as Morse code and alarm buttons, something forward control that can be translated to the OpenHub API and thus support everything OpenHub does.
Yes, but like looking at how the project has gone on so far and stuff, like our focus has been to like get one thing working all the way through as my proof of concept, and then from there we can flush it out a bit more thoroughly on each step of the process.
So for a user using the buttons on the joystick, they would need to program what those buttons will do in their home or their environment.
Yeah.
And then how are you making that easy to do? Like, do they go on the hub and set it up that way? Like, this is what, if I push this button, I want the thermostat to increase by 5 degrees or something.
So because the devices aren't natively designed to be compatible, our goal is to make it as easy as possible. So the step of actually communicating between two devices is probably going to be the most complex step in any of these setups. So our like areas where we can streamline a bit more are by standardizing the hardware with Raspberry Pi, we could just have a file set that you could download onto an SD card and say like use an SD card, it's the correct size, and use a Raspberry Pi, and then you can skip all of the like backend setup process by just downloading, or sorry, you can skip the like software installation process by just copying the data over. Like we can try and streamline as many of those steps as possible. But like the actual setup of communication between devices is probably not something that we can feasibly like make it an easy task. We can just make it a little bit simpler.
Cool. Good with that?
Sure.
So